Now members, we are going to see what happens if they give you capital F of x and then they ask you to get small f of x. This one is called the cumulative distribution function. Then when they want you to get the probability density function, what happens? But we say if you have capital F of x, to get small f of x, you just differentiate capital F of x. But now, this one is not directed because we have a constant. Okay, what happens? Find the value of this constant. Okay, so this is the question now. Now, the idea is very easy. Always you focus on this last class, this last interval in this limit here. So it's that from 1 to 3 means that now this is our capital F of x, the one which gave us 1. But we say, always, when you get in our capital F of x, this one here, which is having k over 2 into 10x minus x squared plus 5. Always, capital F over here, we have been getting a 1. The one that brings us to this. So when you put in a 1 here, when you put in this upper limit here, the 3 shall get a 1. If I do the same there, I'll be adding k over 2 into, I'll be adding now 10 into 3 minus 3 squared plus 15, the whole over. Okay, anyway, over 1 equaling 1. So this will be 30, that 5 minus, this will be 30, that 5 minus 9, that will be 26. So we have k over 2 into 26 equaling 1. And you see that this one is going to give us 13k equaling 1. And so our k will be 1 over 13. So that's how we get that. So meaning that now, here for this interval, means that now our capital F of x, we have our capital F of x here, will be now, so I have this from 0 to, for x, let's say equal to -1, then I have k, which is 1 over 13. Now, can we expand this? When we expand this, we get x squared plus, this is going to be 4x plus 4x plus 3. The interval was -1 less x, less or equal to 0. Then this one was 1 over 13 into 3 plus 4x. Then this was now 13 over, so this will be 1 over 26 into now 10x minus x squared plus 5 for the interval 1 less x. What's the d? Then this one, the interval here is between 0 less x less or equal to 1, and then a 1, our x greater or equal to a 3. Now to get f of x, will be equal to the derivative of capital F of x equaling to b dx of capital F of x. So now, so for the interval now, when I differentiate this, now you know that our capital F of x, it doesn't have this, it's always between the limits. So now when I focus on this, when my capital F of x is equaling to, when it's equaling to 1 over 13 into x squared plus 4x plus 3. Get now small f of x. I differentiate this, which will be f prime of x. When you differentiate this, you get 1 over 13 into 2x plus 4. When I differentiate that, remember I got this by expanding this. So when I differentiate that, I get that. Now for this, my capital F of x is equaling to, this one will be 1 over 13 into 3 plus 4x. When I differentiate this, now I get my capital F of x, f prime of x, which will be differentiate this we get 1 over 3. This is when we differentiate this we get 2, and differentiate this we get a 4, which will be 4 over 13. Then my last capital F of x is equal to the last one, 1 over 26 into 10x minus x squared plus 5. When I differentiate to get my, I differentiate this, which will be 1 over 26 into, differentiate this we get 10 minus 2x, and differentiate this we get a 0. So now, meaning that now my p.d.f, f of x will be, you come and you constant our p.d.f. For the first interval for this, approximately this, you get 1 over 13 for 2x plus 4 for the interval of negative 1 less x less or equal to 0. Then for the next, this one, we got a constant which is 4 over 13. The interval was between 0 and 1. Then for this one, the last one, we got 1 over 26 into 10 minus 2x, which will be for the interval of 1 less x less or equal to 3. Now, we concentrate now on our last interval, this one, a 1, this one here. So that now our last is capital F of x equal to 1. Our small f of x here, we shall differentiate this capital F of x, which will be at 0. So our f of x is equal to 0. So this way we shall say 0 elsewhere. 0 elsewhere. This means that above 3, it's 0. Below negative 1, it's 0. As simple as that, and we have related that. So you can now have as many questions as what you can do to sketch that and so on.